Number 18 on the 2025 AMC 12P problem. Onyx repeatedly plays a game that has probability of winning of 1 over 3. The outcomes of the games are independent. What is the expected value of the number of games he'll play until he has both won and lost at least once? So there are two cases. Either Onyx won the first game, which will become like this, and either Onyx lost the first game, which will become similarly like this. So for the upper one, it is 1 over 3 times 2 over 3 times... Oh, also we have to find the expected value. So we have to multiply the number of games every time and then divide it by the total number of cases. This is 1 over 3 squared times 2 over 3 times 3, because there are 3 games. 1 over 3 cubed times 2 over 3 times 4. 1 over 3 times 1 over 3 to the 4th power times 2 over 3 times 5, and etc. Same thing for here. 2 over 3 times 1 over 3 times 2. 2 over 3 2 over 3 squared times 1 over 3 times 3. 2 over 3 cubed times 1 over 3 times 4. 2 over 3 to the 4th power times 1 over 3 times 5, and so on. So now what we got is, for example, let's say that the number of games is limited at, well, a. Then it will become sigma n equals 1 to a, 1 over 3 to the n power times 2 over 3 times n plus 1. Same thing for here, n equals 1a, n plus 1, 2 to the 3, n power, 1 over 3. Now, because this is n plus 1, we can just change it into n equals 2 to a, and then make it so that it becomes n times 1 over 3, n minus 1, so therefore times 2, plus sigma n equals 2 to a, n 2 over 3 to the n power, and then 1 over 2. Now this, to limit a goes to infinity. So this would be our answer. If it is divided, that will be our answer. Because we multiplied the number times the probability, and the total is the number, the expected number, so the average number times 1, so therefore this makes sense. So now we need to find the value of this. So we need to make a claim. What is n times x to the n power? So firstly, 1 plus x squared plus all the way to x equals infinity equals 1 divided by 1 minus x if the absolute value of x is smaller than 1, which is satisfactory on both cases here, 1 over 3 and 2 over 3. Because also this holds true because if you see a plus ar plus all the way to a times r to the n minus 1 power is equal to a 1 minus r to the n power divided by 1 minus r, so therefore just put n equals infinity and a equals 1 and stuff like that. Now this holds true for all x, so every single x value whose absolute value is smaller than 1. So you can just do dx on both sides, which will give us 0 plus 1 plus 2x plus 3x squared plus all the way to infinity equals 1 divided by 1 minus x squared. Now we want nx to the n power. This is currently nx to the n minus 1 power. So therefore, we multiply x on both sides. X plus 2x squared plus 3x cubed plus 4x to the 4th power plus all the way to infinity equals x over 1 minus x squared. Now we start from n equals 2. So get rid of this x, and then we get x 1 minus x squared minus x equals this thing over here. Now what we have to do is just put in these x values here. So for the first sigma, which I just circled in blue, will become x equals 1 over 3, and then we have to multiply 2 at the end. So x is 1 over 3, so 1 over 3 over 1 over 3, so 4 over 9 minus 1 over 3 that times 2 plus 1 over 2 times, we need to put 2 over 3 on x, so 2 over 3, and 1 over 9 minus 2 over 3. So therefore, we get as a value for 3 over 4 minus 1 over 3 times 2 plus 1 over 2 times 6 minus 2 over 3. That is all equal to 2 times 5 over 12 plus 1 over 2 times 16 over 3. So that is equal to 5 over 6 plus 16 over 6, which is equal to 21 over 6. That is again equal to 7 over 2. Now our expected values answer is 7 over 2. So the answer is answer choice D.